Let's discuss this example. This example is similar to the previous example. Small changes there. Okay. So what we have here, we have a non-empty set X and two metrics are defined on the same set X, D1 and D2, which will satisfy this important inequality for two non-negative real numbers, positive real numbers K1 and K2. This is a very important thing. And what we have to prove? We have to prove that if we have a sequence Xn, it's Cauchy in XD1 if and only if sequence Xn is Cauchy in XD2. So let us prove it. I have written the basic information, given information. If and only if is there, so I will assume one part first, we will try for the second part. I have assumed here sequence Xn is Cauchy in XD1 and we have to prove that sequence Xn is Cauchy in metric space XD2. Using definition, obviously we are going to prove. So let us take one epsilon first. Let epsilon greater than 0 be given. So we have this information, let us use it. Sequence Xn is Cauchy, so therefore there exists n belongs to set of natural number such that see, it's Cauchy in D1, no, XD1. So D1 of Xn Xm less than epsilon for all nm greater than or equal to capital N. See, a small adjustment I am going to do. Instead of epsilon, I am going to take epsilon by K2. K2 is also positive real number, so no need to worry. After that, I am going to shift this K2 on this side. So what will happen? We will have like this. So therefore, K2 D1 of Xn Xm less than epsilon for all nm greater than or equal to capital N. Right? So let us use this inequality number 1. See, K2 D1 of xy is greater than or equal to D2 of xy. So if I use this inequality there, what will I have? So therefore, from 1 we can write D2 of Xn Xm less than or equal to K2 D1 of Xn Xm. We have this is less than epsilon for all nm greater than or equal to capital N. So when we have a less than b, b less than c, we write a less than c. So here also this one is less than this one is less than epsilon. So we can directly write, so therefore d2 of xn xm less than epsilon for all nm greater than or equal to capital N, right? But see, this is definition of Cauchy sequence. Therefore sequence Xn is Cauchy in metric space XD2, since we have a metric D2 here. So we started with sequence Xn is Cauchy in XD1. We proved that sequence Xn is Cauchy in metric space XD2. Okay. So yeah, half part is done. After that, converse part, what will we do? We will start with Xn is, by assuming Xn is Cauchy in XD2, we will prove that sequence Xn is Cauchy in metric space XD1. Make a screenshot of it, then we will go further. See, conversely, I have assumed that sequence Xn is Cauchy in a metric space XD2 and we have to prove that it is Cauchy in metric space XD1. Using definition, we are going to prove. So let us consider one epsilon first. Let epsilon greater than 0 be given. If I use this information and if I apply the definition of Cauchy sequence, we can write, so therefore there exists n belongs to set of natural number such that, tell me what can I write, such that d2 of xn xm less than epsilon for all nm greater than or equal to capital N. Getting simply, I use the definition of Cauchy sequence, but it is Cauchy in metric space XD2, so that's why I wrote D2 here. One more adjustment I'm going to do. Instead of epsilon, I'm going to consider K1 epsilon. Okay, it's an adjustment. K1 is positive real number, epsilon is also positive, product is also positive, so no need to worry. If I use equation 1, actually I removed the equation 1, but as in question you can see there is that equation we have. So if I use it, what will I have? If I use this inequality here, I can write, I will mention here, from 1 we have, yeah, can you tell me what can we write from 1? From 1, K1 D1 of, okay, K1 D1 of Xn Xm less than or equal to D2 of Xn Xm. See, they are given in terms of X and Y, but I'm writing in terms of sequences, okay. D2 of Xn Xm is less than, we have got this is less than K1 epsilon for all Nm greater than or equal to capital N. A less than B, B less than C. So obviously we can write A less than C. So I will, yeah, directly write. So therefore K1 D1 of Xn Xm less than K1 epsilon for all Nm greater than or equal to capital N. So K1 K1 we can cancel from both sides. So therefore D1 of Xn Xm less than epsilon for all Nm greater than or equal to capital N. This is definition of Cauchy sequence. So therefore sequence Xn is Cauchy in metric space X D1, since we have got D1 here. So therefore sequence Xn is Cauchy in metric space X D1. So first we assume, okay, sequence Xn is Cauchy in metric space X D2, and we proved it is Cauchy in X D1. That means converse part also we have proved here, okay. So proof is over. Make a screenshot of it. Then we'll stop. Thank you. Bye bye.